I believe there's only 2 more problems.
Yes.
Okay, so the last 2 aren't anything new, but they combine rules. So we have 3 rules, right? We always use power rule. That's a given. But the 3 other rules that sometimes we use and sometimes we don't, the product rule, the quotient rule, and chain rule, now that we know chain rule, okay? So when it says combining rules, it means either using the chain rule and the product rule, or the chain rule and the quotient rule, or all 3, just depending on what this problem needs, okay? So 5a, take a look at 5a. Off the top of your head, which rules do you think we're going to use besides power rule? Power rule we always use.
Power rule. Change rule.
Chain rule. What part of the chain rule? What part of f of x is going to need chain rule?
Square root 2x minus 3.
The square root part. Good. The square root is going to need chain rule, right? So chain rule. Any other rules that we're going to need? Product rule, right? Because it's x squared plus 1 times the square root, right? So we're going to use product rule and chain rule on this one, okay? Okay, so first thing, always, always, always rewrite if you need to. This one we do. Instead of a square root, write x, or sorry, write to the 1/2 power. 1/2 power, okay? First thing. And you guys are right, we're gonna need chain rule.
That's not the derivative.
Oh yeah, I put the derivative notation, but you're right, it is not the derivative. That would have been easy. This part here, we're going to need to use the chain rule, right? And then when we find the derivative of the whole thing, we're going to need to find the product rule, right? So which rule am I going to use first? Product rule or chain rule? No, it's actually product rule first because we're multiplying these 2 guys. Within that, we're going to use the chain rule, but it's product rule first. Okay, so let's set up product rule. So product rule says first. So the first one is x squared plus 1. Rewrite that. Times the derivative of the second. That's where we're going to use the chain rule. The derivative of this guy, to do that, because it doesn't have a power, if it had a power of 1, we don't need it. But because it has a different power, we have to use the chain rule. So the chain rule, just a review, says start on the outside. So I'm going to find the derivative of the outside. Something to the 1/2 power. Well, anytime you have something to the 1/2 power, you move the power to the front, subtract 1 whole. What is that something? It happens to be 2x minus 3. Chain. Now, to complete the chain rule, you find the derivative of the inside. 2x minus 3, which is just 2. Okay. Now the opposite. The second times the derivative of the first. The derivative of the first is just 2x, because that guy only has a power of 1. Okay? Now, how far do you need to go? Well, first of all, you don't want any negative exponents. You want to multiply everything that you can multiply, and then you're done. So we have 2 terms here. I got 2 terms. I have this guy, and I have this guy, and they're joined by addition. So I just need to simplify each of them as much as I can. Okay? So, let's see. I'm going to multiply the coefficients. That's a coefficient. That's a coefficient. When you multiply those, you get 1. Okay? And then I notice that this guy has a negative exponent. That means it needs to move to the bottom. So I'm going to have a numerator and a denominator here. Okay? So the blue times the blue is just positive 1. Okay? x squared plus 1 just stays on top. The green needs to move to the bottom because it had a negative exponent. So you can put it to the 1/2 power, or you can change it back to the square root of 2x minus 3, because that's how originally it was at the beginning. It doesn't matter which one you do, as long as it's not a negative exponent. The other guy, there's not really anything to do. Move the 2x to the front, and then just change this back to... That's as far as you need to go. Okay? That's as far as you need to go. You don't need to combine like terms or anything like that.
No sign.
Okay? All right. Okay. 5b. Okay, so we got t's instead of x's. So which rule or rules, besides the power rule, obviously, are we going to need to use here?
Might be chain rule.
Chain rule, because we have something to a power, and quotient, because it's division, right?
Yeah.
Perfect. Okay,
What's quotient?
so let's set it up.
Quotient's like
There's no square roots, so we don't need to rewrite it. Okay, so g prime.
G prime T.
So what are we going to use first? Which rule are we going to use first? Last time we used product rule first and then the chain rule. So we need to use the quotient rule and we need to use the chain rule. So which one are we going to use first?
Chain because everything's inside.
Chain, because everything's in the inside. Yep. Because chain rule says start on the outside. Something to the 9th power. Find the derivative of that. And then find the derivative of the inside. Okay? Well, that is going to involve the quotient rule. But first, we have to find the derivative of the outside. Okay? So it's something to the 9th power. So move the 9 to the front. Subtract a power. Chain. Rewrite whatever was on the inside. Okay, so it was t minus 2 and 2t plus 1. Now find the derivative of the inside. The derivative of the inside is where we use the quotient rule. Okay? So low times the derivative of the high. So 2t plus 1 times the derivative of the high, which is just 1, minus the high times the derivative of the low, which would just be 2, over the low squared. Okay, so I need to distribute 1, distribute 2, rewrite it. So 9 times t minus 2 over 2t plus 1 to the 8th. That part hasn't changed from the last step. This part is, though. I'm going to have 2t plus 1 when I distribute the 1. When I distribute the 2, I'm going to have 2t minus 4. And then 2t plus 1 squared. Distribute the negative. So when I distribute the negative, it's going to become negative 2t and positive 4. Okay. Simplify a little more. Let's see. So we're going to get 2t minus 2t is 0. 1 plus 4 is 5. 2t plus 1 squared. Okay, so this 9 is really 9 over 1. It's really 9 over 1, this 9 in the front. Remember, any whole number that doesn't have anything underneath, it's a 1 down there. So the reason I did that is because I'm going to multiply this guy and this guy. So I get 45. So it doesn't really matter where you put the 45. I'm just going to put it over where the 5 was. As long as it's on top and as long as it's there. Oops. No. 2t plus 1, 8th power, 45, 2t plus 1 squared. You could move it to where the 9 was. That's okay. You can do that there. Or you could put it where the 5 was. Either one's okay. Because it's all multiplication. We're just multiplying those two, the two fractions. Okay. So if you were to put that answer, look for that answer, because this would most likely be a multiple choice question. If you were to look for that A, B, C, D, you wouldn't find that answer anywhere.
Oh, no.
The reason is, what do they have in common? Look at both of them. Look at both fractions. They both over 2t plus 1, right? So what you can do here to simplify it is, so this first fraction here, if I have a fraction to a power, that means the top gets that power and the bottom gets the power. That's what it means. So like if you had 1/2 to the 4th power, that means 1 to the 4th over 2 to the 4th. That's what the rule says. So I'm going to rewrite it to distribute, in other words, the power.
Oh, God.
Okay. Now, how do you multiply fractions? Straight across. So we get 45 times t minus 2 to the 8th power. Right? I can't distribute 45 because it's got a power of 8. So I'll just leave the 45 in front. The bottom, though, you notice that these two guys, they both have the same base, right? There's a base and then there's an exponent. So what are the rules? If you have two bases that are the same, what do you do to their exponents? Add them. So you're going to get 2t plus 1. Instead of 8 and 2, you're going to have 10. Now you're done. Now you simplified it. Okay. All right. Since we got plenty of time, I want to give you 2 practice problems. The very, very back page, the last page, you should have plenty of room there. I left it blank. Or if you have room on that page, wherever you got room. Okay, so I'm going to give you, I gave you 2 practice problems on Friday, and I'm going to give you 2 today. Okay, so let's see. So we'll call this extra practice 3 and 4. Okay, so finding the derivative, here's the first one. (3x over x plus 1 square root). And then number 4 is y equals secant.
No. Wow.
Okay. I'll give you a hint. You're going to use more than one rule for each.
I could have, might have been a good guess. That kind of sucks, though.
Okay. So do those, then we'll go over it in about 5-10 minutes. Used the quotient rule. You could use product rule, but I just use quotient rule. Which one's easier? They don't really make a difference. It's going to be, you're going to run into some walls either way. The key is just breaking through them. Sometimes the first time it works. Sometimes you got to kind of go back to the drawing board and keep going. So when I did, this is what I got. Try to put it all in the same. So low times the derivative of the high minus the high times the derivative of the low. To do the derivative of the low, I had to do chain rule. Okay? Over the low squared. The low was to the 1/2 power times, if it's 1/2 power squared, you just multiply the powers and you get 1 power of 1. So that's how I got no power here. And then I kind of distributed, cleaned it up as much as I could, and then I stopped there. Okay, I'm not done, but I just stopped there just because to go any further, I wanted to explain it. Okay. Okay, so to match their answer and to get rid of a fraction over a fraction, because you should never leave a fraction over a fraction, I need a common denominator. Right now, the denominator is 1 here. The common denominator, I have one denominator as 1. I have 1 as x squared plus 1 to the 1/2. This guy, the 1 needs exactly what this has. This already has the 1. The 1's right there in front. You got to multiply the top and bottom by what I need. Okay? So I'm going to multiply this by x squared plus 1 to the 1/2, x squared plus 1 to the 1/2.
Did he subtract 1?
All right. So now I get both of them have the same common denominator. And then I have this guy times this guy. If they have the same base, you add their exponents. So it's going to be x squared plus 1 to the first power. So I have 3x squared plus 1 to the first power. Minus, I didn't touch this guy because he already had the same common denominator. And then the bottom is just x squared plus 1. Now I can combine them because they have the same common denominator. So x squared plus 1 to the 1/2 power. And then I get 3, I can distribute this actually. I can actually distribute that to get 3x squared plus 3. Minus 3x squared. These two guys cancel out. X squared plus 1. Okay. So now I have 3x squared plus 1 to the 1/2 over x squared plus 1. So now I still have a fraction over a fraction, but at least it's one fraction over a fraction. It's not 2. Keep, change, flip. Keep the first one. Multiply, change the second one. Oops, that's going to go on the bottom. To the first power. You get 3 over x squared plus 1 to the 3 over 2. Yep.
Would it not be,
This thing.
would it not flip?
It did flip.
So we have this, and
This isn't a fraction.
this here.
Now it is a
the
fraction.
half goes away because you multiply it by this when it's a fraction. So
'Cause
that
it's-
has the same denominator.
Over 1 like that.
Then
And I flipped it.
I would this.
Okay.
Why do I have that?
Okay, so I hate to say it again, but we stopped doing calculus a long time ago. So if this is where we kind of lose everyone, right? Go yell at Mr. Yates because he's the one who taught you this.
What did Yates do?
He did not teach it.
I do not remember learning this in Yates.
He should have taught you this because
Then
this.
again, it's been
I'll
2
be
years.
honest, I don't think
years.
he's taught us this.
Okay, so
It's been 2 years.
It's been 2 years.
honestly, we were done with calculus or up here. Everything below the red line was algebra. Okay.
No. I've heard more in this class.
No, but I could do it quotient rule.
Okay.
I can't do it product rule.
I know, I can do a quotient, but I couldn't. I'm gonna tell him to.
I can do
he
product,
tell
but
history
I'm
honors this year.
ending with like
It's a good idea.
3x squared times.
Tell him instead of going off on tangents like he does to actually,
Oh, that's real, that's real.
Plus.
right? I've seen him teach. When he's actually, when he goes off on a lot of tangents. Yeah. So, again,
Find the derivative of that.
I could do
Oh my
quotient
God,
rule,
yeah,
but I
it's
can't do product rule.
when,
I have to like think about it.
yeah, so after, below that, so before that red line, that's the derivative. That's technically a derivative. But again, you need to simplify it because A, that's not going to be one of the 4 answers on the A, B, C, D. So you got to be able to simplify it, but that's all kind of prerequisite. Like what I used to do is give a summer assignment, and then the first week we had a test on all of this kind of stuff, right? I stopped doing that just because to see if it worked both ways, but because I didn't really like giving a summer assignment, but that was the kind of thing that was on it. Like simplify this, a lot of simplifying stuff, because that's what we do a lot. Factor and simplify. Those are the things that you guys learned in Math 1, Math 2, Math 3, even before that, right? Okay, so is that a lot of steps? Yes, but it's not nothing you can't do because you have done it, right? I'm pretty sure if I gave him this and said, have you taught him how to simplify in these, he would say yes. I don't know if you remember it, but like I said.
That's what he's gonna say. Is like if they remember it, that's a different thing.
Yep.
That's exactly what he's gonna say.
Okay. 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 Number 4 is actually a lot easier than number 3. I don't want to say easier, it's less complex. So first thing I did was separate, I don't want division, I want a fraction. So I changed it to 1/7 times secant to the 7th power and minus 1/5 times secant to the 5th power. That's the first thing. Once you do that, it kind of falls into place. You just use chain rule. All you have to do is use chain rule. You don't have to use product rule or quotient rule. I moved the 7 to the front. That makes 1. Took away a power. Found the derivative of the inside. The derivative of the inside, secant tangent. Minus. Did the same thing. Right?
He's not really gonna
So, what I got was secant of x to the 6th power times secant times tangent minus secant to the 4th times secant times tangent.
No, it's because
That's the derivative.
this is quotient.
But to match the answer, we got to simplify.
I stop here because I couldn't.
So let me color code it.
So you,
So I stopped
I don't
there.
think you actually get the same answer.
No, we just
So-
do it, right?
I have to do some.
You have one term here
Do it quotient, I can't do it product.
and one term here.
Dude, product is my thing. Why can't I do product? I'm so sad.
You could simplify it. I have secant to the 6th and secant to the 1st. Multiply them, you get secant to the 7th. So you're going to get secant to the 7th times tangent. And then down here, the magenta, you're going to get secant to the 5th times tangent. That's how they got their answer here. What, they went a step further than that. Okay, so what they did was they combined these two, so it'd be secant to the 7th, secant to the 5th, right? Got this, girls? The quiz next week is going to be fun if you can't focus. Yeah, we got a quiz next week. Okay, so please focus. Okay?
But no, explain to me like this.
And then you're going to do, so let me write it down here.
Wait, no. Wait, yeah.
Yeah.
What?
I can't do product rule. Oh, I think I understand. Wait.
I'm trying to figure out how to
I
do
don't
it.
know how to do product rule.
So I get secant of x to the 7th times tangent
Because we have this.
minus secant of x to the 4th times tangent.
Wait.
That's where I left off.
Wait. I might understand it. Wait, I understand it.
Okay, wait, let me write this down. Continue, let me see. Number 4, continue. Okay. So now you just see, oh, well, I can take out these two terms. I can divide them. The GCF of these two terms is tangent.
But I understand where he's coming from. Where like you can get rid of these.
We just need to figure out how to get rid of this.
And the,
That's what I need help.
actually, no.
Because like we get that, and those get canceled out. That's because
But where does this go? That's
where does it? Oh wait, no.
So they both share secant of x to the 4th power, because they both have at least 4 secant of x's. And a tangent.
I understand where he's getting the 3 now. I understand a bit more.
yeah, but where do we cut this? We cancel that.
Okay? So that means secant of x to the 4th times tangent of x. What's left over? Well, you're going to have secant of x to the 3rd minus 1. Yes.
Why was the secant to the power 7 and not 6?
Oh, was it 6? Did I write that there wrong?
Oh, I was just wondering because it
Oh,
was
perfect.
supposed to be.
Oh, 6, but then I combined it with this guy because it's multiplication.
Oh.
So this is
yeah.
power 1, power 6, 7. Okay? Just like this was power 4, now power plus 1, you get 5.
But didn't you put 4 in the other one?
Did I? Let's see.
Or the continuing part?
The which part?
The one you were continuing? It was like it said.
Did I write it down wrong? Let's see. Let's see. What did I leave off? 6 and 4. Yeah, it should be 6. This should be 6. Yep. 6. So that should be 2. And this guy is nothing. Sorry. I don't know why I wrote that. It's minus 1, just minus 1. Because these guys cancel out and those guys cancel out. They become 1s. It doesn't match the answer. I don't know why it doesn't match the answer without having to spend more time on this. See, that would be secant squared. So that would, this is, oh wait, that should be a 4. That should be a 4. And times tangent, that's the GCF. Okay. What's left? Secant squared. Because these guys cancel out. Minus 1. And I know what they did. You don't need to do this, but that's an identity. That's an identity there. Can't remember what identity it is, but that's an identity. That's why they have, it's either tangent, might be tangent. Tangent squared. This guy is tangent squared. You don't need to know this. But to match the answer, this is what they got. That's tangent squared. So they multiplied this to get that. You don't need to know that. This is good enough for me. Okay. Now these are two like extreme, I don't want to say extreme, but they're on the difficult side of questions you're going to see. Okay, so are all problems going to be like this? No. So when I build your tests, when I build your quiz, so let's say there are 6 problems on the multiple choice. Let's say you have 6 problems on a multiple choice test. What I do is I do one easy, one difficult, and the rest medium. These two I would call difficult. So you might have one of them on a test. How do I determine easy, difficult, or medium? They tell me. My test generator tells me. But these would be considered difficult questions. Will you see them on tests? Yeah, but I mean, it's 1 out of 6. All right, most of them are medium. So the ones we did on our notes, I would say most of those are medium, maybe a few easy. All right, let's say. Because people want to know, how do you build your test? Like this one, I would consider a medium to difficult. This one I would consider pretty medium, maybe even easy because you didn't really do a lot. This one here I would consider medium to difficult. Medium to difficult. These I would consider easy to medium. Some of them, like the first couple, I would say they're pretty easy, straightforward. Anything that's straightforward, anytime you hit like what I call a brick wall, if there's stuff you're like, oh, I don't know what to do here, that's when it goes from easy to medium or medium to easy or medium to difficult. It depends on how many times you got to think. Okay, that's how I usually build my tests and quizzes. So if there's 4 questions on a quiz, one of them's going to be easy, one of them's going to be difficult. Most of them, majority, are going to be medium. Okay. So like I said, will you run into like problems like we just did there? Those are a little more in-depth than usual. Okay. So I want to give you guys a complete day to work on a chain rule, because we do have a quiz next week. It's not till the end of the week, so it's not till the end of the week. We got plenty of time. But usually every 2 weeks I do a test or a quiz. We did a quiz last week at the end of the week, so we'll have a quiz at the end of next week. Not this week, the end of next week. What's going to be on it? Chain rule. Chain rule stuff. Okay? Chain rule stuff. So that's why I want to give you guys time to practice it. Okay? Practice it. That's what I want to see. Practice. I want to see practice. Okay? So that's what we're going to do tomorrow. All right?